The notes in front of you. Did I mute you guys? Like no one's gonna respond to me?
We can see the screen.
Thank you, Jacob. Appreciate it. Okay, let's do some old school adding and subtracting fractions. So if I have 5/7 plus 1/2, what do I need before I can add fractions?
Common denominator.
Thank you. Geez Louise. Common denominators. So we have common denominators and we have lowest common denominators. So a common denominator would be 28. So both 7 and 2 divide evenly into 28. But we want to always try to use the lowest common denominator, so in the end we don't have to simplify too much. So what's the lowest common denominator between 7 and 2? 14. So you guys got 14, and I'm assuming the way you did it was you took the two denominators and times them by themselves. 7 times 2 gave me the 14. Right? I'm assuming that's how you did it. So here's the thing, is that when we're doing this, we need to get a denominator of 14, so we multiply by the missing factor. But we have to multiply top and bottom, because 2 divided by 2 is a value of 1. So these have to be the exact same, because that doesn't change the value of the fraction, it just changes how it looks. And then over here, we multiply by the missing factor. And when I say missing factor, this one already had the 7, this one here had the 7, so I needed to multiply by the 2. This one has the 2, so I need to multiply the 7. The reason, okay, you guys are like, Sky, and we know how to do this, but the reason why I'm breaking down the steps for you is so that when we do it with letters, everything is exactly the same. So you're multiplying by the missing factor of your common denominator. This, now that they both have the same denominator, we keep the denominator of 14. The denominator does not become 28. We keep that denominator because we worked hard to find it, and then we just add the numerators. So 17 over 14. Okay? Easy peasy. Easy peasy. Okay, so let's go through the steps. I gave you an example up here, but I don't think it's helpful. So factor both the rational expression. So you're factoring everything. That's what we always do. Factor everything, state the MPVs, simplify within each term, and we only do that if possible. Find the LCD, so the lowest common denominator. Multiply each rational expression by the factor, well, the factor that's missing. Just like we did before up there with our basic math. And then we're going to add or subtract the numerators, keep the LCD as the denominator, factor the numerator if you can, simplify again if possible. Okay, so these ones, I would encourage you to leave yourself a lot of space. I would encourage you to do any factoring off on the side of the page so that the math of just adding is what I see. Okay, so let's go ahead, and step 1 is factor everything. So I'm going to common factor out of 3 there. Well, I'm using erasable pens today, so it's much nicer. Denominator here is a difference of squares. Add, and then this is a difference of squares as well. So that's going to be 2x plus 1, 2x minus 1. Hey, did you guys notice that that was a difference of squares? Did that pop off the page at everybody? Okay, so this one has that coefficient in front. So I'm going to grab a piece of scrap paper. That's my attendance. And my scrap paper here, let me fold it in half. So I'm going to factor that denominator. So 2x squared plus 9x minus 5. So I multiply the 2 by the negative 5, so I get negative 10. What are the factors in negative 10 that add up to a positive 9? I'm going to be 900 by the time we get through this lesson.
Positive 10 and negative 1.
Thank you. So this is going to be 2x squared plus 10x minus 1x minus 5. So again, when we're factoring this, these are just that in a different form. I'm looking at these two. I'm going to common factor. I'm going to take out a 2x. I'm going to be left with x plus 5. I'm going to look at these two, and I'm going to common factor -1, and I'm going to be left with x plus 5. So I know I've done it right if these two are the exact same. So my factors are going to be x plus 5. So those are gone. And then 2x minus 1. So I did that on a scrap piece of paper because I don't want to actually clutter up. I don't want to clutter up the math. I don't have a lot of room on this page. So, okay, so here we are. Step 2, so we factored everything, which is step 1. Step 2 is our NPVs. Just going to scooch them in up here. So non-permissible values, x cannot equal, and we're just looking at the denominators, right? So this one's going to be -5, this one's going to be +5. So that's plus minus 5. This one's going to be a -5, which I've already written, so I don't need to write it down again. And this one's going to be a +1/2. Okay, so I've done my MPV. So I've done step 1, I've done step 2. Step 3 said to simplify within each term if possible. So this is a term and that's a term. So in step 3, we're just simplifying within that term. So I can cancel out this and this. And in this one, I can cancel out this and this. The reason why we want to simplify within the term is because we want to make it as small as possible when we do our LCD. Again, you don't have to simplify, you can wait until the end, but you're going to get a lot more binomials and bigger things in there. Okay, so we have now our step 4 is to find the LCD. So what is the common denominator? I'm going to write this down over here. Okay, so this is, I'm going to switch back up to...
Don't you just times them? So wouldn't just be the different squares? So the
Absolutely.
X squared equals 25.
Yep, but my friendly reminder, don't ever multiply anything through. Not yet. Like, so...
You put them together?
Yeah, so I'm just going to put them together as if just a step before multiplying them. So I'm going to leave it like this. So my LCD are just the two denominators multiplied together. Pretty straightforward. Okay, so in my first term here, what's missing? I have the x minus 5, so what's missing? I have this one, so I'm missing the x plus 5. So I'm going to times top and bottom by x plus 5. Pavlo, use brackets. Make you feel better. All right, so if I go over to this one, I have the x plus 5, so I'm missing the x minus 5. All right, so now what I'm going to do is I am going to, what do I want to do? I'm going to multiply this, I don't know. Ooh, I'm using a pink pen. I hope you all can see that. Over x plus 5. X minus 5. There's a few steps that I probably will skip later on, but I think for our first example, I'm going to keep them all on top. So this is going to be x plus 5, x minus 5. Okay, so that seemed a little redundant to rewrite that, but I did. So I'm going to scooch that. I'm moving up here because I didn't leave myself enough room. So what I'm going to do now is I'm actually not going to multiply the denominator through, but I am going to multiply the numerators through. So I'm going to do some leapfrogging, right? So when I come up here, this is going to be 3x plus 15 over x plus 5, x minus 5. Okay, so now I've got 2x squared minus 10x plus x minus 5. Oh, I feel like we've been here before. All over the common denominator. All right. So now we're just going to go ahead and we're going to add the numerators only. So we're going to keep our denominator of x plus 5, x minus 5. And now we're going to add our numerators together. So I've got 2x squared. And then I've got a 3x minus 10 plus x. So that's going to give me negative 6x. And then I have positive 15 minus 5. So that's going to be a plus 10. Okay. All right. So the next step, these are lengthy. So the next step is I'm going to see if I can factor this. So what are the factors of positive 20 that would add up to negative 6? And if you don't have time for this in your life, this is where your quadratic solver comes in pretty quickly. So I'm going to go 2, it was negative 6, and then 10. Solve the equation. Okay, so what I see here is, so I know a couple of things looking at this. This I means imaginary. So I actually know that this is unfactorable. This equation here is unfactorable because there's no real answers. My discriminant from chapter 4 is a negative 44. So I know that my discriminant is negative, therefore it can't be solved, therefore I can't factor it. So I used a little bit of chapter 4 to solve that. So this is actually where we end because this is not factorable.
Can't
So
you common factor it though?
I could, you're absolutely right, I could common factor it, but, talking and writing at the same time obviously is too difficult for me this morning. X plus 5, x minus 5. But the reason why I would factor it is to go ahead and cancel stuff out again. And by common factoring out that 2, it really doesn't help me cancel anything else out. But it might help me see that this is unfactorable quicker. So this, ladies and gentlemen, is your final answer, but comma x cannot equal plus minus 5 or positive 1/2. So that is my answer.
So we don't actually times the denominator, we just keep it in like the pre-leapfrog.
Yeah, I would keep it in the factored form because if we could factor this, then we would see if we have to factor that and then we'd have to cancel stuff out. So if you're going to have to factor it anyway, you might as well leave it in factored form. Make sense? Clear as mud?
Would you deduct March if we didn't?
Nope. I will tell you where I will deduct marks. If you multiply this through, let's say you multiply that through to be x squared minus 25, and this was factorable, and you could have simplified it further, then you'd lose a half mark for not giving it to me in the most simplified form. But for this question, if you multiplied those through, that would be 100% correct because we couldn't simplify it anymore. Good? Golden? Everybody got it? Can you do this in your sleep? Okay, I need you all not to panic if this isn't easy right away. Because it's not meant to be, okay? It is what it is, and it's a little bit lengthier, but it's okay. We're actually going to graph these things. I'm super pumped. You'll learn about asymptotes for the first time. That's coming up in chapter 7.
Oh, thank God. I thought you were about to say we're doing that today.
Oh God, no. We couldn't do all of that in one day. All right. So exciting. Example numero 2. Okay. Factor everything. Step 1, factor everything. Oh wait, it's already factored. Step 2, non-permissible values. These are the hard ones. They're the easiest ones, but they're the hard ones. Hey, what's the denominator on the 3?
Well, 1.
1.
But wouldn't it just be like x equals 0?
X cannot equal 0.
And then y cannot equal 0?
Y cannot equal 0. That's a really light pen. I'm gonna switch. Yes, so just remember when they're monomials, so when there's nothing added or subtracted to them, it's always gonna be 0. Okay? This has a denominator of 1. Even though it's not stated, we all know that any number has a denominator of 1. Any variable has a denominator of 1. It's pretty exciting stuff. Okay, so we factored. Can we simplify within a term? Can we simplify in this term? Can I cross stuff out in this term?
dx.
The x. So those are gone. So that's going to leave me with 2 over y. And let's simplify here. Another x. So that's going to be plus 4 over x. Because this is like saying x times x, right? So only one of those x's would get canceled out. Anything we can simplify in the minus 3? Nope, there's nothing the same on top and bottom, so there's nothing we can do. So that's our most simplest form, so that's good. So now let's do our LCD. What are we doing to the denominators, folks?
Wouldn't it just be x times y?
Yep. You're just multiplying the two denominators together. Well, 3 denominators, but do I need the 1 out in front? Are you guys okay if I don't write the 1?
No. Yes, you're okay.
Okay, all right, okay. I asked 2 questions there. Okay, so that's my LCD. So now what we do is we go through, I'm gonna find a red pen. We go through and see what's missing. So my LCD is XY. So if I look at this term, what's missing? It's the x, right? So I'm going to multiply this one by x over x. And then if I look at this term, what's missing? What's missing from the bottom? The y. Right, so it's y times y. And then if I look at this one, what's missing from the bottom?
X and y.
X and y. Okay, so you getting the hang of this? Like it's a little bit, maybe? No? All right. So I have 2x over xy plus 4, oh, that's, I'll write the 4 in front. 4y over xy minus 3xy over xy. Okay, ladies and gentlemen, once you get a common denominator, please don't start canceling stuff out, because that's going to put you right back up to this line. And then you're going to be in this like infinite loop where you just keep crossing stuff out, adding it back in, crossing stuff out, adding it back in. You only simplify within the term in this third step. Once you've found the common denominator, you keep the common denominator of xy, and then you do the operation along the numerator. So I'm going to have 2x plus 4y minus 3xy. Where x cannot equal 0 and y cannot equal 0. And that is my answer, because I can't combine any of these terms. We good?
Yes.
Okay, thanks, Sander. I appreciate that. All right. Example number 3. Example number 3. We are going to factor everything. So really, this one right away I think, oh, perfect square, difference of square, sorry. Perfect square in the front, ooh, not a perfect square in the back. So I'm not going to factor that. I'm going to factor that though. So even though it's a y squared, I'm actually just going to leave it because it doesn't factor nicely. I will tell you that this, that in this unit, we're going to be doing things that factor nicely. Okay? Like there won't be any decimals or weird things like that. You're not going to get the root of 20 or weird stuff like that. Okay, so I factored everything. Now I'm going to do my NPVs, my non-permissible values. So y cannot equal plus minus 2, because that's a negative 2, that's a positive 2 when I solve it. And then this one will be a negative 2, which again, I've already stated, so I can just leave my non-permissible values at those. Okay, so I'm going to simplify within the term if I can. Is there anything I can simplify here?
No.
Pablo's not killing kittens. This is a good day for us. Is there anything I can simplify here?
No.
No. So there's nothing I can simplify, so that step doesn't happen. So now I'm going to find my LCD. What's my LCD? What do both of them share? Let's start there.
Y plus 2.
Y plus 2. So I'm only writing it down once. So that's that. So what term now do we need to multiply by? What's left?
Y minus 2.
Y minus 2. Thank you, Madison. I appreciate you being the voice amongst the empty bubbles I see in front of me. So sad. So as you can see, this is the LCD. Okay? That's not a stretch for you guys, because if I had 1/2 plus 3/4, you guys would say our common denominator is, or our lowest common denominator is 4, because 2 and 4 both divide evenly into 4. Now you could use the common denominator of 8, but then you'd have to simplify. So this would be the only one that I'd times 2/2, and we'd go from there. We wouldn't touch this one. And that's essentially what we're doing right now. So sometimes you have to do it to both, and sometimes you only have to do it to one. But you guys have done that with fractions. So this has the LCD, so I'm not touching it. This one only has the y plus 2, so it's missing the y minus 2. All right, so I'm going to multiply everything in. I'm trying to pick pens here. So I got, well, there was nothing to do on this one. That's easy, just rewrite it. I'm going to multiply these two binomials together. So I'm going to get y squared minus 4y plus 4. I skipped a step there, folks. And notice that I'm not multiplying the denominator. I'm not multiplying that in because I just want to see later I might need it. Okay, so we're going to go ahead and we are going to combine like terms on the top. So I'm going to have 2y squared minus 4y minus 16 all over y plus 2, y minus 2. I'm going to common factor out that 2. Because Madison taught me that. Makes it easier for me to see if I can factor it. Are there factors of -8 that would add up to a -2?
Positive 4 and -2.
Flip it and I'll agree with you.
Oh, sorry. Well, whatever.
Whatever. Same thing. Hey, you're doing your best. You're carrying the class here.
I'm not even doing the math. I'm laying in bed right now.
I love it. So your notes are going to be fully incomplete?
I'm screenshotting the questions and filling them in later.
Okay.
Her unwritten notes are still better than mine.
Probably. Okay, so this one's a really good example. So this one we could continue to factor. So I factored this into this. Now what do?
You crossed it out.
I crossed stuff out, my favorite part. And I'm left with 2y minus 4 over y minus 2, where y cannot equal plus minus 2. I'm just going to put brackets around it for Pablo. So that's it. That's the end. That's all So you see the benefit of keeping things in factored form on the denominator, just so I don't have to go back and factor that again. It's kind of redundant. Okay, so if everybody's good with that, I'm gonna flip the page, and it's never a good sign when I give you an entire page to do a question, just FYI. And these ones look terrible, but they're not if you break them down. So the way I deal with them is I deal with it two things, because I have fractions inside of fractions. Okay, so I've got the numerator, I've got the denominator. Oh, you can't see that. So the numerator, and really, what does this line mean mathematically? What does that line in a fraction mean? What does 1/2 mean?
Divide them.
Divide. So really, we're taking our numerator and we're dividing it by the denominator. You guys would agree with me? Mathematically speaking?
Yes.
Yes, thank you. Everybody else is still sleeping. Okay, so there's my numerator and my denominator, and this is how I always deal with fractions inside of fractions. We're gonna do these in grade 12 with trig, and it's super fun. No, it's not super fun. I really like it, but no one else seems to. Okay, so let's look at the numerator. We're gonna treat this as its own rational expression. All right, so factor everything. Done. What's my NPV for the numerator?
X cannot equal 0.
Okay, I just put this over 1 because now I'm making it a fraction. Okay, now I'm going to hop to my LCD. What's my LCD for just the numerator?
X.
Just X. I heard myself there. Okay, so this one has the X, so that's all good. So this one has to be times by X over X. All right, so if I do the math, that's going to be X over X plus 1 over X. Now, this makes sense. X divided by X should bring me back to 1, but you're not going to do that. Don't simplify here, because you've worked so hard to find that common denominator. Don't simplify. Okay, so now I'm going to keep my common denominator of X, and I'm going to add the numerator. Okay, good job, everybody. Good job. Let's go over to the denominator. All right, what is my NPV?
X cannot equal 0.
X cannot equal 0. All right, what's my LCD? This has a 1, this has an X. What's my LCD? X. Poor Madison's carrying the class. Where are the rest of the voices?
I feel bad. I don't want to say all the answers.
For sure. No, totally get it. So this one's going to have to be multiplied by X.
Good morning, Danica.
Hi.
I love it. I miss you guys. I miss when I don't get to see your faces. X squared minus 1 over X. Ooh, I skipped a step there. Is everybody okay with that? Maybe not. Let me go back.
Did you record the lesson?
Is this Danica?
Uh-huh.
You showed up. How are you, sleepyhead?
I didn't sleep
Okay.
until like 8.
Oh, well, I'm happy that you're here. And yes, I am recording the lesson.
Okay.
Okay. So this was a step that I skipped. So X times X gives me X squared. 1 times X gives me X. And then I didn't do anything to this one, so I recopied it down. Keep the denominator of X. Okay, so this is good. So we said that these are all just divided by each other. So the numerator, X plus 1 over X, divided by the denominator, which is X squared minus 1 over X. Okay, this is good. This is good. So now this is just a division question from yesterday.
Is there like reciprocal in this?
Yes, 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 yes. But before we reciprocal anything, does anything leap off the page at you? If I gave you this question yesterday,
Cancel out the X's
Oh, Pavlo.
That was me. Not
I know it was you, but it's definitely a Pavlo move.
I'm not the only one putting buttons now.
Yeah.
Can you flip the second one and then cancel the X's?
Oh, okay. You're on the right track, but before you
Janika's
crazy,
on a roll. She just started.
she just showed up and she's on fire. Okay, so before we do any of that, if this were a yesterday question, what's step one?
Get the NPVs of the reciprocal.
No, step one.
Factor.
Oh, is that a
Factor. So,
Factor though is the second one because it's a difference of square.
exactly. So hopefully you guys are getting to the point in your math where you can see this and this should leap off the page at you as I have to do something else. You guys are like, sure, whatever. Okay, so here we are. We've factored everything. We know the NPV. We did those up here, 0 and 0. All right, so when we are going ahead and we are doing a division question, we reciprocate only the second one. We change it to a multiply and we flip the second one. Okay, before we get crazy and start canceling stuff out, what do I have to do now?
New MPV.
New NPVs, because you have a new denominator. New denominator. So we have new NPVs. Okay, so what are my new NPVs? So the old one was x cannot equal 0. What are my new ones?
Plus and minus 1.
Beautiful, plus and minus 1. Okay, so now you crazy kids, you can start canceling stuff out. So yes, the x's go away. What else goes away? X plus 1s go away.
Yeah.
Okay, so what's left on top?
1.
1. Okay, that's huge. Some people put zeros and that like it kind of blows my mind as a math teacher. Yeah, but we know that x divided by x is 1, and we know that x plus 1 divided by x plus 1 is another 1, and if we times 1 by 1, that's still 1. So there's never nothing left if we've crossed stuff out. It is a 1. Oh, who earns? I'm not using an erasable pen. I don't like that. X minus 1. I get excited with my brackets. And that would be my final answer. So I actually think these questions are not terrible if you break them down. Some people are magical. They can see this, they can see the whole thing as it sits as a fraction within a fraction. And these people are magicians. Like, I can't see that. I'm not a visual person. I like to work it out on the page. So if
the
you,
screen.
yeah, I'll,
Yeah, can you move it so I can screenshot?
No, to the right. Yeah.
that.
No, so I can screenshot like the whole question.
Like the
And can move the
you-
camera, like whole page. with-
You want to see the whole page? You want me to zoom out?
Yeah.
Yeah. What is the light blue? You can barely see her.
That's as good as I can get for a whole page kind of thing.
Thank you.
So I always like to break it down as numerator divided by the denominator, because I find that makes a lot more sense to me. And then this went here, and that went there. And by the way, this is green. I know. I
It
gotta,
looks like turquoise. You know?
which is nice, but it's not really great for these sort of things.